All right, welcome. Today we're going to pull back the curtain on the digital world. We're talking about the fundamental architecture, the stuff that powers literally everything you use, from your favorite social media app all the way to these massive global systems. So let's just get right into it.
You've done this 1,000 times, right? It feels so simple, almost like magic. But behind that one little action, there's this incredible, super high-speed journey happening in the background. So, what is actually going on there?
Well, at its absolute core, pretty much every single web application you use is built on this thing called the client-server model. Think of it like this. Your browser, or maybe the app on your phone, that's the client. It's asking for information. And then somewhere out there, there's a really powerful machine, the server, that gets that request, figures out what to do, and sends a response right back.
Okay, but that brings up the first huge challenge, right? The internet is this massive global network with millions upon millions of servers. If you just send out a request with no specific address, that's kind of like trying to mail a letter with no street name on it. It's just not going to get there. So how in the world do we find the exact right one?
Every single server that's hooked up to the internet gets a unique ID. We call it an IP address. And honestly, the best way to think about it is like a phone number. It's just a specific set of numbers that tells your request exactly where it needs to go. Simple as that. Without it, nothing would work.
But, there's a problem here. A human problem. We're just not built to remember long strings of numbers, right? And that's exactly where the DNS, or domain name system, comes into play. It's basically the internet's phone book. It works just like the Contacts app on your phone. You type in an easy name like google.com, and the DNS does the hard work in the background, looking up the correct IP address. It makes everything feel totally seamless.
Okay, so let's imagine our website is a huge hit. It's gone viral. That's great news, but it also creates a brand new problem. Our one little server is totally overwhelmed with traffic. So what do? How do we handle this massive flood of requests without the whole thing just crashing?
Well, we've got two main ways to tackle this. The first is called scaling up, or vertical scaling. That's where we just make our one server more and more powerful. More CPU, more RAM, the works. But there's a ceiling to that. And worse, if that one super server fails, everything goes down with it. That's a single point of failure. The other approach, which is usually the way to go, is scaling out, or horizontal scaling. Instead of one big machine, we just add more servers to the team and share the work. It's way more flexible and a whole lot more reliable.
But wait a second. Now that we have all these servers, how do we decide which one gets the next request? That's where a load balancer comes in. It's like a traffic manager or a traffic cop standing in front of all your servers, and its only job is to direct the incoming requests evenly across all of them. This little piece of technology is literally the reason your favorite shopping site doesn't just completely collapse during a massive sale like Black Friday.
And this whole process isn't random at all. Load balancers use specific strategies to make these calls. The most basic one is called round robin, which is super simple. It just sends requests to each server one by one in a rotating order. But there are smarter ways too, like the least connections method will send the next request to whichever server is the least busy at that moment. It's all about making sure the work is spread out as efficiently as possible.
All right, so we've figured out how to handle all of the incoming traffic. That's awesome. But what about the data itself? The user profiles, the product information, all those social media posts. Where does all of that stuff actually live?
It really comes down to two main camps. On one side, you have SQL databases. The best analogy for these is a super well-organized filing cabinet. Everything has a very specific, predefined place in rows and columns. This is perfect for stuff like banking, where you need rock-solid consistency. Then, on the other side, you have no SQL databases. Think of these more like a giant, flexible whiteboard with sticky notes all over it. The structure is dynamic, which makes it perfect for handling tons of unstructured data at a massive scale, like what you'd see on a huge social media platform.
So here's the next bottleneck. Going to the database to get information can be kind of slow. And if you have data that people are asking for over and over and over again, those trips to the database really start to add up. We need a shortcut. We need a way to speed things up so our app feels snappy and super responsive.
And that's exactly what we're going to do. Create a shortcut. Just think about it. Imagine the front page of a big news website. If thousands of people are all requesting the exact same handful of top stories, does it really make sense to have our database do all that work every single time? No way.
This is where a concept called caching becomes our best friend. It's such a simple but powerful idea. Here's how it works. The very first time we need a piece of data, we go get it from the database. But then we store a copy of it in a super fast layer of memory called a cache. Now the next time anyone asks for that same data, we don't go to the database at all. We just serve it instantly from the cache. And that is dramatically faster.
And this idea of caching isn't just for data from a database. A CDN, or Content Delivery Network, does the exact same thing, but for files like images and videos. It's this huge global network of servers that stores copies of your content all around the world. So let's say a user in India wants to watch one of your videos. They don't have to get it from a server in New York. Instead, the CDN serves it from a much closer server, maybe one right there in Asia. This just slashes the load times.
So let's take a quick step back. We've got clients, servers, load balancers, databases, caches, all these different pieces. But you can't just throw them all together and hope for the best. To build a system that's actually robust and can scale, you need a really detailed professional plan. You need an architectural blueprint.
And this is the structured way that architects actually think about it. It's not just chaos. They start at a really high level with a conceptual idea, like what is the business actually trying to do here? Then they move down to a logical design where they map out how all the different software parts are going to talk to each other. And then finally, they create a physical architecture, which is the nitty-gritty plan for the actual servers, the networks, and all the hardware involved.
And that blueprint, which is often a formal document called a solution architecture document, is incredibly detailed. I mean, it doesn't just list the parts. It goes deep into how data will flow, what security measures are needed, exactly which technologies we're going to use. It even calls out potential risks and lays out a plan to deal with them. It really is the master plan for building the whole thing the right way from the ground.
So there you have it. From one simple request all the way to a globally scaled system, you now have the foundational knowledge of how it all clicks together. And these aren't just, abstract ideas. These are the real tools that engineers and architects use every single day to build the digital world around us. The only question left is, what problem are you going to solve with